And thank you again for joining us today. We're recording this session, and we're going to get started now. We're lucky today to have two gateways featured as part of our showcase. And the first presentation will be by Dr. Greg Madey, who's at University of Notre Dame. And he'll be talking about the Ensayo Project. And then that'll be the first half hour. And then the second half hour will be about the Spaces Gateway, which stands for Spatial Portal for Analysis of Climatic Effects on Species. And that will be presented by Dilkushi de Alves Pitts. I hope I pronounced that right. And she's at the University of Cambridge. And so they will be taking questions during their presentations by chat. Also towards the end, I'm sure that you can unmute yourself and ask questions as well. Greg is happy to take questions at any time during chat, and you can submit your questions just clicking on that chat icon at the right side of your screen, and I will let him know if questions come along. And then, but Dilkushi prefers to have questions saved to the end of her presentation. So with that, I will hand it off to Greg, and thank you all again for joining us, and here we go.
Okay, thank you, everybody. I'm Greg Madey from Computer Science and Engineering at the University of Notre Dame. And the other two critical people on this project right now are Cindy Nicolai and Sam Naroke. Without Cindy and Sam, nothing would have happened. This project was part of Cindy's PhD dissertation, and it's currently part of Sam's master's thesis. Sam, Cindy, and I are also affiliated with the Center for Research Computing at the University of Notre Dame. So the word ensayo is Spanish for rehearsal. So we were working on a project that involved training for a disaster, and one of our collaborators at the time thought that the Spanish word ensayo was a good trademark to give the project. So that's why it's called the Ensayo Project. The actual product that we'll be describing now is called SimEOC, short for a simulator of an EOC, and it's a web-based virtual emergency operations center simulator for training and research. So it's got two purposes, training and research. So I'm going to start out with maybe half of the presentation being an emergency management overview, so you understand why SimEOC was designed to be what it is. So in this space of disaster management or emergency management, there are a variety of disaster types, and they could be biological. I see these should be in alphabetical order here, but this could be a pandemic. This could be bioterrorism, for example. Chemical could be a hazmat event, an explosion at a chemical plant or a refinery. It could include civil disorder, earthquakes, fires, floods, heat exposures, hurricanes, transportation accident, an airplane crash, or a railroad incident. And you can see all the different types of disasters. And there are more, and there are a lot of different taxonomies out there as to how you would classify the different types of disasters. But in this discipline, what they try to do is train for all hazards. So the systems that you put in place and the training is not necessarily specific to any one of these. It's kind of the superset of all of them, so that you're prepared for whichever disaster comes along. So we're talking about an emergency operations center, but what is that? So this is a picture of the Miami-Dade EOC. This is a training event where as many as 100 people have shown up, and they're going through a simulated disaster. And these people that show up don't work for the EOC. They're coming from an agency or an organization in the community that has resources that could be put to bear for the recovery or the response after the disaster. So notice on the next slide, we have here a floor plan of the Miami-Dade Emergency Operations Center. So in the center, you'll see those 3 rectangles. These are literally 3 tables. And I'm just looking up at the top. There's the U.S. Coast Guard. There's the Miami-Dade Fire Rescue. DERM, I think, is the Department of Environmental Research, Resource Management. This is like Park Police and so forth. U.S. Coast Guard, let's see, National Park Service, Florida National Guard, Miami-Dade School Police. Turns out that the public school system has their own police force, and these resources could be brought to bear during a disaster or an emergency. If you look at the center rectangle in the middle, there's Human Resources Branch. This includes people in the community, that include organizations in the community that include the Salvation Army, the Greater Miami Convention Visitors Bureau, Red Cross, public schools, public housing, animal services. If you go down to the bottom table, you'll see as an example the transit system, the water management district, water and sewer, Miami-Dade Transit, Miami-Dade Public Schools, because they have lots of buses. If you're going to be evacuating people, you put those school buses to use. The Parks Department, they have heavy lifters, front loaders, cranes, and tractors that could be brought to bear in response to disaster. If you look at the tables off to the left, the vertical lines to the left, you'll see FEMA, you'll see FDEM, the Florida Department of Emergency Management. You'll see neighboring counties. Each one of them has an EOC, and a variety of other organizations. Now, some of these squares on this table here could actually be represented by 2 people, possibly more, because during a disaster, say a hurricane, you may have to go 24 hours a day waiting for the hurricane to approach. Everybody's shut down while the hurricane's overhead, and then several days after a recovery. So you have to have several shifts. So some of these representatives in the room, representatives of these organizations, may have to be working on multiple shifts. So where do you find EOCs like this? Well, most large cities have them. New York City has their own. Chicago has its own EOC. Most counties, even the smallest, will have EOCs, although the rural counties tend to have things that are considerably smaller. At every state, at the state level, there should be an EOC. I think every one of the 50 states have one. And then at the state level, there'll be a National Guard. These are the people that have the heavy equipment that come out and rescue people during a flood or evacuations during fires or whatever. And they have trucks and bulldozers and what other types of equipment that could be used for disaster response. They'll have their own EOC. For public health reasons, there may be an EOC inside the state Department of Health. Federal agencies that are responsible for disaster response will have their EOCs. Universities have EOCs. We have one here at Notre Dame, and I'm pretty sure that all big universities have EOCs. Large corporations will have them. Airline, for example. Imagine a major airline accident where an airliner goes down. They'll have to activate the EOC and start to deal with press releases and coordination of recovery and dealing with the hardships that are caused by the accident. And of course, all large corporations that have logistics that could be affected by weather, for example, FedEx, UPS, they have to have emergency operation centers. So what do? Their responsibility is to provide the coordination of a response to disaster. This could be things like evacuations, rescue, assistance, providing shelters, food, blankets. The EOCs are a central secure location where the representatives from those agencies and organizations gather. The EOC doesn't actually make decisions, it doesn't actually do the response recovery. That's done by the people that have the resources. So if it involves police, the police department will send a cruiser, or if it's fire rescue, they'll send the resources. The EOC is just there for coordination. So it's coordination among all those representatives. It's command and control, a unified situational awareness. There are conversations that happen inside the EOC to determine who's going to do what. And once that decision is made, there is a recorded commitment as to which agency is going to take responsibility to get something done. So if we're talking about if we're talking about training for an EOC, there are some challenges. Those in-person those in-person exercises, and that one that I showed on that photo inside the Miami-Dade EOC is called a functional exercise. Those are costly because you may have as many as 100 people showing up. They're taking a day off from work. You have to provide coffee and donuts, and of course, they're not on their regular day job. So it's costing everybody a lot of time and money. So you usually in a community don't do more than a few per year. They just don't want to commit valuable resources for more than one or two such exercises a year. Now, the challenge is that these are people that come together, but they really, for a disaster, they come together for disaster, but they rarely work together on their day-to-day job. So this presents communication problems, understanding the meanings of terms and even knowing who I'm supposed to talk to or the name of the person I'm supposed to be communicating with to clarify something. And then the other challenge is that these people, these representatives that show up at the EOC when there is a disaster, there tends to be high turnover. They get promoted, they leave the jobs, they transfer. So there's this constant training and making sure that communication problems are avoided. Because when the disaster comes, you don't want those problems. And so there is a need for more frequent training, but perhaps at a lower cost. The tool that we built, SimEOC, is also designed to be a research platform. So there are research questions that we could address with this tool. It could be performance analysis. How well, under what circumstances does the EOC perform well, or when does performance start to degrade? And are there changes in the organization and the communication channels within the EOC that could improve or degrade the performance of the entity? And we could do the research by actually visiting the few in-person exercises, but the problem is those are only a few a year, and it is difficult to inject yourself in there as an observer. And then from a research point of view, there's also a lot of needs from a research point of view of getting a good trace of what everyone's doing to kind of understand where the bottlenecks or problems are. So the need for SimEOC was to have a research platform that supported experiments and post-experimental analysis. So this is the technology stack behind SimEOC. As I mentioned earlier, it's a web-based EOC simulator for training and research. We use virtual machines. We use Nginx as our web server. We use the mean stack, and we use Bootstrap. So now I just have a series of slides that I'm going to walk through fairly quickly. This probably could be done in a few minutes here, so I'll just move along. And I'll just comment on the slides as these screenshots as I walk along. So this is the login page to SimEOC as it exists today. And you notice in the upper right corner, there's an opportunity to log in or sign in. So I'm going to sign in. And after signing in, I've chosen an ongoing exercise that I want to join. And this is a severe weather exercise. And notice in the middle of the screen in the top, you'll see the word playing. That means that the exercise is actually taking place. I can see a list of the people that are players in this simulation. And on the far right, I see a blue button that lets me enter the exercise. So if I click on the enter exercise button, I get to a screen that looks like this. Now I have it in its most simplified form. The 5 blue icons that you see at the far left and the 2 dark blue icons that you see at the right are widgets that pop out or fly out if I click on them. And in the middle here, these are all widgets that provide some functionality, and they can be expanded by clicking on the little arrow to rotate and expand or collapse the widget. So what I'm going to do is click on the current exercise status and expand on that. And you can see that I'm actually entered a simulation that we use for some testing, and it's actually been sitting dormant, but it's actually registered as running for 24 hours. But it just indicates that it's playing, its status is playing. So I'm going to close that and then click on the players widget. And you can see I can get a list of everybody who is a player. And at this moment, they're all logged off. And this actually is a screenshot, so there's more names in the list. So I'm going to close that one and open up another widget, and we get some media. There could be media that we have to be registering inside the EOC, or in this case, the virtual EOC, about press releases that we're giving to the outside. We also have in this simulator what kind of social media we might be seeing. This could be Twitter, for example. I'll close that one and open up missions and tasks that had been assigned to me as a player in this simulation. I'll close that and open up the disaster map that everybody who's playing in the simulation can view. I've closed that one and opened up a widget called the status board. And this is kind of the situation awareness for everyone that's in the EOC. There are resources like hospitals or shelters where you want to have a common awareness of what's going on for everybody who's in this central location. So it might be the number of available slots at an emergency room. It could include the open or closed status for shelters. That's what's being simulated in this to the right. I'll close that widget and open another one. This is a little bit about my personal activity in this simulation. Okay, now you'll notice in the upper left, I clicked on one of those flyout widgets. This one's called injects. So one of the ways that the training simulator works is that all the people are in the room, in this case, the virtual room, and then the people that are running the training exercise, they're called the exercise controllers. They inject into the simulator simulated messages, events, or responses that individual players need to respond to. Now, right now, I don't have any inject that's been sent to me, but this could be a request for me as, say, a representative of the police department to send some police cars to a particular intersection. And that would be injected into the simulation as a substitute for real requests that would take place during a real event. So let's see. Another widget that I've expanded from the left is the logs. This is a personal record that I'm keeping of my position log. And this might be the position that might, for example, be shared by 2 people, different shifts. We were using it in this exercise as a way for doing some testing. So I was just entering in some of my observations. Over on the right, we had a widget that permits us to do one-to-one communication, and we do have the ability to pretend that it's an email communication, a text communication, face-to-face, mobile, or landline. And there is an ability to have group chats, a small meeting to simulate several people getting together in the EOC, but doing it virtually. Okay, so this is our acknowledgments. One of our collaborators is Troy Johnson from the Miami-Dade Office for Emergency Management, Mike Petrulla, Emory University, Irma Becerra Fernandez, St. Thomas University, Center for Research Computing at Notre Dame. And this work has been funded by a variety of grants over the years, some of them to Florida International and Emory, and the rest of them to the University of Notre Dame. So thank you. Are there any questions?
Thanks, Greg. There was one question posted by Mona who asked if it's possible for anyone to get an account for the SimEOC and actually do the exercises.
Yes, this is set up to be a shared research platform that we're going to make available to academic, scientific researchers anywhere who wants to use it. So have that person send me an email. Is my email address available online?
I can put it on the posting for the
yes
with the information about in the video and so forth. So yeah.
We're actually welcoming people that would like to get on and start using it, because it could be a research platform for your own research, and that's one of its goals.
Well, that's really neat. A question from Emily is, could you comment on the development process?
So it's we're using sort of a informal spiral model. We also use what we call the in the entrepreneurial mode, the what's it called now? The minimum viable product. So we spent about 6 months for each spiral of our spiral development, and at the end of our first spiral, we had what we call the minimum viable product, and we're now in the process of refining the requirements, and well into our second spiral right now. I hope that answers that question.
Emily, you're welcome also to unmute yourself if you wanted to ask further questions about that, or if that was good enough. I'll throw in another question here that came in from Carol Song while you're thinking about that. Carol asked, who would configure these exercises? How do you add new facilities related to emergency management?
Okay, now that is something I completely ignored there. I was just showing you what the trainee sees, or the human subject would see. There's a completely different interface that is used by what's called the exercise developer. There's a role that a person could play, which is the exercise developer. So that would be the trainer imagining what's the simulated disaster going to be, and how am I going to engage all the players in the exercise, so that you have a reasonable simulation of a disaster going on that engages everybody. It includes developing a list of those injects that I made some reference to, and they are scheduled at a certain time to take place. The exercise developer can also take a secondary role of being the exercise controller, or that could be another person. So when the actual exercise is taking place, there's this one person that's kind of watching and maybe speeding up time or slowing time down, possibly adding ad hoc injects. Maybe it looks like one person isn't getting enough work, or they're too efficient, so we could give them a little bit of extra tasks to keep them busy. So while the trainees, or the human subjects, are role-playing through a disaster training or being human subjects, there's an exercise controller which is running the simulation. And so that's a completely separate set of interfaces that I didn't bother to show. So there's a lot of flexibility for you to design your own disaster, and what events happen, and who the players are, and what their names are called. And we've set it up so that every user of this has their own private space. So your exercises are separate from everyone else's.
Thanks, Greg. We have about 3 more minutes before we switch over to Dilkushi, and Emily followed up with another couple of questions because she doesn't have a microphone, and it says, she said, thanks for the initial response. When did collaboration with the Center for Research Computing at Notre Dame begin? How is the broader development team scoped and organized?
So the current grant, well, actually, what I have to say is some of the earlier grants were supporting Cindy's dissertation, and some of the early work was done by Cindy, the PhD student. We then brought in the professional developers at the CRC to help with the prototype. So the version that we have right now is sort of version 2, if you would call it. The first version was developed and then developed as part of Cindy's dissertation, and then given some refinement. So CRC helped us with that refinement, and that goes back about 4 or 5 years ago. We made a decision to completely change the technology. We were doing some PHP and some older open source products that weren't very robust. So that new technology stack forced us to completely start all over again. But it was a good exercise because we had pretty good development, or the requirements worked out. What was the second part of the question?
How was the broader development team scoped and organized?
Well, the development team, this is a small project. The development team just consisted of 2 people, and that was Sam Narogi and a second woman, Beth Caldwell. So the development team were just 2 good CRC programmers who were familiar with JavaScript, and we chose Node.js so we could have JavaScript on the back end and the front end. And they were both web developers, so they were familiar with Bootstrap, and so they've been working on it for about 2 years, well, about a year and a half now, and our funding only supported that size team. I hope that answered the question.
It sounds like it might have. I'm sure Emily will pipe up by text. Oh yeah, she said that's great. And then one final question before we switch over to Dilkushi. Mona had asked, has this system been used in a real training situation?
No, not yet. At the moment, we've hired a student intern down in Miami-Dade that's going to work with our collaborator there, and we're going to get the group of people down in Miami-Dade to become familiar with it. And we're hoping later this summer that we'll be able to start doing some training. We've also reached out to the people that own the EOC at the University of Notre Dame and the EOC in the county that we're located in. And we're not sure yet, but we think we might be able to get them interested and maybe do some real training, but we're not at that point yet.
Great, thanks. There's another question that came from Emily, and we'll let you answer that while you sign off with your slides and
okay.
Slides up.
Okay, I'll stop sharing.
Thank you for that, Greg, especially. So Dilkushi, if you'd like to get your slides up and share your slides while we swap over. The question that was for Greg was, did the CRC have enough visibility at Notre Dame that you knew to reach out to them? Otherwise, how did you learn about them?
Oh, I've had many collaborations with the Center for Research, so they were the natural organization for me to go to. This was one small project. I've had a variety of other projects where I've gone to them. And the CRC at Notre Dame is about 10 years old now. I think we just celebrated the 10th anniversary. So I've been working with them over that entire period of time.
Oh, that's fantastic. Well, and I should mention, too, as we hand off now to Dilkushi, that her project is also supported and was developed with help from the Center for Research Computing at Notre Dame. So, so this is a double header, I think is maybe the term you call it anyway. So thank you so much, Greg, for that presentation, and I really appreciate you taking the time to share that. And now we'll hand off to Dilkushi, who will talk about the Spaces Gateway.
Thanks, Catherine. Can you hear me?
Yeah, we can hear you great. And I'll just remind folks that we're going to save questions for you until the end.
Okay.
Go ahead.
So I'm going to talk about Spaces again. I'm currently at University of Cambridge, but I was at University of Notre Dame when I worked on Spaces, and I was a part of CRC, in fact. The Center for Research Computing at the University of Notre Dame. And the collaborators are Jarek Nebrisky, the director of CRC, Jessica Hellman, Jason Durasing, and Talmo Algua. So Spaces is short for Spatial Portal for Analysis of Climatic Effects on Species. And as you know, change in climate alters land use and land cover. And then that can reduce and fragment species habitats and increase frequency of destructive not native species. So to deal with these environmental shifts, ecologists are increasingly called upon to make risk management decisions that affect natural resources. And because of this, there's a rapidly growing need for species distribution models. So next, I will give you a short introduction to species distribution models. Sorry. Okay. So let's assume I found some species in Cambridge, around Cambridge in England, and if I look at the environmental and climate data where I found the species, I can probably find a niche, a comfortable area where these species would thrive. So, for example, if I look at the temperature and rainfall data for where the species were found right here, and plot them on a graph of temperature and rainfall, you'll see that the species were found in areas where there were more rainfall, and cold areas, temperature low and rainfall high. So basically that alone is an environmental niche for the species. And you can increase the climate variables. You can include environmental variables like soil moisture, digital elevation, and really narrow down the niche for different species. So there are models that do that. For example, I've shown you 3 examples of models. There are models that look, if this is the niche, it would select this area and show all the geographical locations associated to that niche. And there are other models that are very constrained or conservative. They would be very, they would leave some outliers off, and they would consider more dense niches only and leave the outliers off. So there are many ways of collecting niches, and it gets more complicated when you include environmental data like land use and digital elevation and all the climatic data. And this can be done on projected data, future climates as well, modeled future climate data as well. So the species distribution modeling has been used to quantify the environmental niche of species, just like I showed you now, and revealing potential unsurveyed sites of occurrence for rare species. So you find a certain species, and then you find the niche, and then you find where other places where this particular species could thrive in the world, and those are the unsurveyed sites that the species distribution models can tell you. Also, you can find appropriate conservation and management sites for species. So when you know that this rare species is in a particular place, you can conserve it, and you know what extent the conservation area should be geographically through a species distribution model. And also you can look at bio and eco-geographic regions for species introductions, and test ecological and evolutionary hypothesis that's been done. And also look at the potential of invasive species, like in crops, pests in crops, current and future invasions can be modeled in using species distribution models. These are some of the some of the publications on species distribution models, some of my favorites. So using species distribution models, you can look at closely related species. You can look at invasive species and distribution shifts due to changing climates. Here it talks about extinction risk from climate change, and undiscovered species like these unknown reptile species in Madagascar. Also, you can look at diseases. Understanding habitat requirements help estimate the distribution of disease vectors. And this is for malaria, Anopheles gambiae mosquito in Africa. And these are some of the latest publications on species distribution models, where they have looked at habitat quality and behavior trade-offs, and also rare species occurrences, as well as migration and assisted migration. So, species distribution models have been used by biologists, conservationists, ecologists in many of these applications. So what we did in Spaces was we created a portal where the users can go and get their species data from a species global bio species portal, where they can get locational data. I'll talk about it further. And then we provided the climatic and environmental spatial data in the portal, along with species distribution models, so that they could look at model it and look at predict the distribution of species in geographic space. And if you and the species locational data was taken from Global Biodiversity Information Facility, and that place has about 1.6 million species, records of species, and it varies from mammals to plants. They have records on fungi, bacteria. So basically, what they have is latitude and longitude, locational data for the species and the date the species was cited. That's what they have. So we let the users log into our portal Spaces and grab data from GBIF once they enter the name of the species they're interested in modeling. And as you know, spatial data comes in many incompatible formats and extents and geographical projections. remotely sensed data, that's satellite and data collected from airborne imagery. They come as images, and they need different specialized processing software. And some come as segments, spatial data in segments, and they have to be merged, omitting overlap. And on top of that, species distribution models have their own formats and their preferred data extents. So what we did was we took all the data and created it to fit the species distribution models. Each model had its own characteristic format, so we converted it accordingly for each model. So in species distribution models, generally the spatial data should be in ASCII grid format, and it should have the same spatial extent and resolution, and should have the same geographical projection, and it had to have the same dummy values, missing data, and the data had to be consistent. In other words, if we gave it land use values in the 1980s and 2000, the values had to be consistent. So if in 2018 they called it mixed shrub, and in 2000 it was called just shrub instead of mixed shrub, we had to make it consistent across years, so that it was stable, and it was a good input for species distribution models. So having done that, in Spaces, we give the users the following sample of what we give them. The annual mean temperature, mean taken over the past 50 years, annual precipitation, digital elevation, soil data, then temperature of the warmest month, and mean temperature of the driest quarter. Then I go on. We also have precipitation of the coldest quarter, precipitation in the driest, wettest quarter, etc. And other than the current data, we have on our website, on the portal, data simulated for 2050 and 2070 forecasted data using different emission scenarios. As for species distribution models, we have 24 species distribution models. I have just shown a couple of them here. The most popular species distribution models, namely BioClim, is a very popular model, and generalized linear model, generalized additive model. They are very popular models. Of course, MaxEnt and artificial neural networks. So they fall under three categories: profile techniques, regression-based techniques, and machine learning techniques. So we have species distribution models under all these three categories. So as for Spaces, we let the user get the data from GBIF, species database, and then we let the user select a mask. So the user can select a continental mask, a country mask. The user can also add a mask, upload a mask, and the user can select the environmental layers as well as climate data, future and current climate data. Then the user can select algorithms, one or many, up to 24 algorithms, and adjust the parameters pertaining to each algorithm, visualize the data. I will show you that in detail, and run the algorithm. So Spaces, once you assign it to run, it queues your job, and then it goes and gets the input files, and it combines it with the SDM models, and stores your input files, the input parameter, and the SDM models for later use, because the user can recall the run and rerun the same thing by changing certain parameters as and when needed. And once the species distribution model is run, the user gets an email notifying that he has finished that it's been done. And then once it's been done, you can get the data. You can download the output, or you can take the layers and overlay it back on the Spaces portal and look, zoom in, pan, and change the visibility, order, and look at the data in detail. Also, you can perform some statistics like derivative maps, so you can do some map algebra. So you can, in other words, do a comparison between species distribution models, and you can add species distribution models, or you can subtract the regions and look at what was more conservative and why, according to different categories. And you can also share your experimental files. You can share your results with the community. In fact, Spaces was integrated into a collaborative project done by biologists, and it was integrated where they could share their outputs with decision makers and lawyers and people like that, and rerun experiments and have conversations on that. So this is basically the Spaces model. You have to sign up, and I'm going to log in here. And once you log in, you can start a new experiment. That's what I'm doing at the moment. I'm starting a new experiment, or you can bring up one of your old experiments. And I'm going to look at the mosquito Anopheles gambi, and that's a species name. It goes and looks for it in GBIF and displays the data. You see the data here displayed. And also you can select the mask you want. You can upload the mask or select the mask you want. And then it's simply plug and play. You can select the data, climate data you want. So here I'm showing you mean temperatures, annual precipitation. It takes a little bit of time to upload the data, but because they're large data sets. And then this is the digital elevation model map for the whole globe, and isothermality. Then I can show you the land cover map. Next. Okay, so that's isothermality and the land cover map, and I can go on. I think I can show you the temperature of the warmest month as well. And then you can then go and select the species distribution models you need from the, or you can at the moment what I do is I select all the layers. For this run, I select all the layers. You can select just some of them, and you go to the Run tab and select the algorithms you like, and the species distribution algorithms. So here I select maximum entropy, and then you can go and alter the, you can run it, or you can also alter the input parameters. There are certain parameters that you can alter. And then you get an email saying that the results are ready. Once the results are ready, you log in back and go to that experiment, and you can visualize the results on Spaces other than downloading it. The email gives you a link to download it. And also you can do a calculation. So you can go and compare and contrast the output or the extent of the niche that species distribution models predicted. You can also compare and contrast with your former runs and with your former data and parameters to see the change in extent. And after you run the calculator, you can see basically the output on the screen. So what Spaces has done is it has enabled biologists to take advantage of spatial data otherwise inaccessible, while freeing them from the time-consuming, laborious, and error-prone conversion process. In fact, we started Spaces. We got the idea to have a portal, a Spaces portal, that was in 2011. Was because the biologists at Notre Dame had problems converting data, and the data were too large to handle. So that's when, and there were two groups at the biology department working on species distribution models. Before too long, we realized that they were using the same data, and there were duplication of storage of these massive data sets. So that's when we got some internal funding to create this Spaces portal. So Spaces make data accessible in a format that's standardized with respect to spatial extent and resolution, and avoids duplicate storage of massive spatial data sets. Also provides virtual high-performance computing facility to people from developing countries. Basically, we would like to promote courses on species distribution in developing countries. We have tried that, and it doesn't affect the progress because it's all done behind the screen, and it can be used from all over the world. And it contains documentation that's not currently available, and it creates and manages a platform for a virtual community, and permits the direct comparison of model results with respect to spatial extents. So and Spaces lets you also upload your own species data, while you can get species data from, I have already mentioned GBIF, IUCN and RedList. I have used the IUCN and RedList at University of not University, but Cambridge. Their headquarters are at Cambridge, and SpaceLink and Mantis. So that's where you can get species data. If you don't have any species data, you can upload the species data to Spaces and do exactly use all the other facilities as well. And I thought I'll mention there are other SDM models, species distribution models. BCCVL does something very similar to Spaces, mostly, and it has different species distribution models as well. Open Modeler is another portal where they have some species distribution models and some climate data, not the environmental data. Princeton, at Princeton, you can download one species distribution model called Maxent, and Desktop GARP is another model that you can download from this place. And LifeMapper and MOL are other mapping software that you can, with one or two species distribution models. So in conclusion, this is where you can go and log in and get access to Spaces. And if you have any further, if you need any further information, please do contact me on either of these emails.
Fantastic. Thank you so much, Dokushi. We did get a couple of questions that came in.
Okay.
One of them I think you partially answered, which was asking whether Spaces uses high-performance computing to run jobs. But yes. I think the second part of the question, though, which perhaps you can answer, is which which one or ones are you using as far as resources to do that HPC? Using what HPC resources are you using?
Yes, we are using CRC, that's Center for Research Computing at Notre Dame. That's where it is located. So that's where all the data and that's where the resources are. And we are also looking for collaborators. So if you would like to work on spaces or integrated great spaces to any of your projects, we would love to hear from you all.
Terrific. Okay. And then also, and I'll just mention, by the way, while we're asking you additional questions, I put in a link in the chat section for putting in a 30-second evaluation feedback. So we
okay. You need this.
Oh yeah, yeah. There we go. There's the link for that as well. And next month will be the data carpentry topic. So mark your calendars for that for May 10th. But there is another question for you, Dilkushi, which is from Yan Liu from NCSA, and who asks, are all the output spatial raster data? Otherwise, how to do map algebra on vector data? And then there's several other parts to this question, so I'll leave you with that first.
So that's a good question. So the input data is spatial raster data. They are ASCII grids, and the outputs are also spatial raster data, and that's why we can do map algebra on that.
Okay. And then it says, where does map algebra happen, in the user's browser or a backend server? If the latter, the backend server, how do you manage the computation?
Yes, it happens back on the server, and it takes a little time. On the map algebra takes a little time, and it does send you an email when that's done, and you can really work on it. But if it takes a lot of time, but generally it takes a few minutes, and you see a busy signal on that, and then you just get the image on the map again, because it's basically what it's doing. It's taking one grid and subtracting another grid or multiplying it by a value. So it doesn't take a lot of computation to do that.
Okay, great. And he provided another question, which is, what does it cost to add a new model algorithm? How much automation has been done to speed it up?
So that's a good question. Well, it is not. It's in terms of, it depends on the model itself. If it's a R model, it would be easy. It would be not very hard to plug and play. But because all the other models are written in R, and so it's not that easy. That's something that we are looking funding for, to make it more of a plug and play, where the users can add data and add models. At the moment, the users can't add data and add models to spaces, but that is something we are interested in, and we have not received funding for that yet. But that's something that we are interested in. It is not easy. You can probably work with us to add a model if you're interested. We can work together and get some grants for that if that's something you're interested in. At the moment, I'm working remotely, but we are very interested in expanding this further.
Fantastic. I think you actually ended up answering Carol's question as well, which was, how do other researchers put their algorithms into the portal? So it sounds like they should contact you if they want to get involved that way. Yep.
If you have anything that you're interested in, please do contact us. We could collaborate on a grant. We'll get the money together and we'll work on it, because it was all funded by an internal grant, and we did all the work within 1 year, and we are open to other possibilities.
Fantastic. Well, that's great. There are no more questions that have come through, which is perfect timing as
Great.
we're wrapping up right now at the top of the hour. So I want to thank you, Dilkushi, and also Greg for presenting with us today. And just so everyone else knows who's attending this webinar, the slides and a video of this will be posted in the next day or two on our website, and we'll send a link around to everybody who registered. So thank you, everyone, for participating, and to our presenters for preparing some really engaging presentations about their gateways. So thank you so much.
Catherine.
Yeah, have a good rest of your day.
You too. Bye-bye.
Bye.
Thanks, Catherine.